Spacecraft and space technology. Since the early days of human civilization, the dream of conquering space has always existed in the human mind. Today, with the remarkable development of science and technology, we have made significant progress in building and developing spacecraft as well as space-related technologies. Types of spacecraft. Manned spacecraft. Manned spacecraft are one of the most powerful symbols of progress in space research. NASA's Apollo spacecraft, with the mission of bringing humans to the moon, made history in 1969. The success of the Apollo program not only opened the era of space exploration, but also demonstrated the extraordinary ability of humans to overcome their own limits. In addition, Russia's Soyuz spacecraft also plays an important role in bringing astronauts to the International Space Station ISS. The Soyuz has been in continuous service since the 1960s and remains the primary means of transporting humans into space to this day. Unmanned spacecraft. Unmanned spacecraft, such as Curiosity and Perseverance, have made important discoveries about other planets, especially Mars. These probes not only collect scientific data, but also help us better understand the history and structure of the red planet. Robots, such as the Hubble Space Telescope, have provided valuable images and information about the universe, from distant stars to galaxies. Cargo spacecraft. In addition to carrying humans into space, cargo spacecraft also play an equally important role. SpaceX's Dragon spacecraft is a typical example, carrying cargo and equipment to the ISS. Northrop Grumman's Cygnus spacecraft also performs similar missions, contributing to the maintenance of the International Space Station. Modern space technology. Launch rockets. Launch rockets are the most important factor in putting spacecraft into orbit. SpaceX's Falcon 9 stands out for its reusability, helping to reduce the cost of each launch. Europe's Ariane 5 rocket has also proven its efficiency in putting satellites into orbit. Reusability technology not only saves costs, but also reduces the amount of waste in space. Ship control system. Spacecraft control technology has developed strongly with many advanced automation systems. These systems enable spacecraft to autonomously perform complex tasks without astronaut intervention. From landing to data collection. Materials technology. Ultralight and durable materials are used in spacecraft construction to reduce weight while ensuring safety. The development of these materials has helped to increase the heat resistance and durability of spacecraft when flying through the atmosphere. Space communications. Satellite communication systems play an important role in ensuring communication between spacecraft and Earth. GPS positioning systems also help spacecraft determine their exact position in space, serving the purpose of navigation and performing missions. Energy and power supply. Modern spacecraft use solar cells as their main source of energy, helping them operate continuously in space. Liquid fuel systems provide energy to rockets, allowing them to reach the necessary velocity to leave the atmosphere. Future trends. In the future, plans to explore Mars are being vigorously implemented, with the goal of sending humans to this planet and building a base. NASA and SpaceX are collaborating to carry out this mission, promising to open a new era in space exploration. In addition, deep space exploration is also being focused on. Missions to planets, such as Europa and Titan, where life is likely to exist, will open up exciting exploration opportunities. Reusability technology will continue to be developed, helping to reduce costs and increase access to space for many countries and organizations. In addition, deep space exploration is also being focused on. Missions to planets, such as Europa and Titan, where life is likely to exist, will open up exciting exploration opportunities. Reusability technology will continue to be developed, helping to reduce costs and increase access to space for many countries and organizations. In the 1960s, the space race between the United States and the Soviet Union was in full swing. NASA launched the Apollo program with the goal of landing humans on the moon by 1970. Apollo 1, originally designated AS-204, was the first manned flight in the program, scheduled for February 1967. The tragic incident on January 27, 1967, during a ground test at the Kennedy Space Center, a fire broke out inside the Apollo 1 capsule. 3 astronauts, Virgil Gus Grissom, Edward H. Byte II, and Roger B. Chaffee, were on board when the incident occurred. The capsule's locking system and 100% oxygen atmosphere allowed the fire to spread rapidly. Despite rescue efforts, all 3 astronauts were unable to escape, and they died in the fire. The legacy of Apollo 1. Although Apollo 1 never made it to the moon, the astronauts' sacrifices were not in vain. The Apollo program continued to evolve, and just 2 years later, Apollo 8 became the first manned mission to orbit the moon. Finally, in 1969, Apollo 11 successfully landed humans on the moon. The images and names of Grissom, White, and Chaffee live on in the public eye. NASA learned many valuable lessons from the tragic events of Apollo 1, which helped protect the lives of astronauts on subsequent missions.